Okay, today I have some Ctcss encoder decoders from quite a long time ago. I think these were made either in the late 70s or 80s, sometime back then. And they both generate and encode and decode Ctcss tones for tone squelch. And all these boards are the same. This is an FT128 tone board here, and it uses a MC3403L quad op amp, which is right here. The tone frequency is set by this 10-turn pot here. This controls the frequency response of a bandpass filter. This is all done analog, there's no digital here. And then this trim pot here controls the level of the output. And I believe, from what I see in the specs here, it'll put out, I think, about a volt out maximum, 0 to 1 volt adjustable. And of course the inputs are here. It's got power, black and red, and then it has various pins for tone out, tone in, receive audio in, and some other functions here. It's quite versatile. Unlike the more modern tone boards that have dip switches and are digital, this one, this is completely analog. There's a bottom view of the board. All the parts are mounted vertical here to give it a low profile. It's pretty small. This can be used in any of your old transceivers that didn't have a built-in Ctcss encoder decoder. Most of all the new ones do, but some of the older ones, I've got some older units that don't have the capability. You have to add an external tone board like this. And of course you can only adjust it to one frequency, so it's not real versatile in that sense. You know, if you're traveling around and want to change frequencies and the if you wanted to change the PL tone, you'd have to remove the unit and readjust the frequency on it. So it's pretty much good for using one repeater or one area. So the next step, let's look at the schematic and see how this thing is done, or how they did it back 40 some odd years ago. Here's a schematic of the Ctcss encoder decoder, the FT128. Anyway, the signal is applied to pin 3 here, and it's coupled through a low pass filter, which is created by IC1 here, and it's coupled through C7, R7, and R8 to IC1B, which further amplifies it. And it looks like the output here is clipped. The positive and negative portions are clipped, converting the signal into a square wave, and that's applied to this bandpass filter here. And IC1C and D create a bandpass filter, and its frequency is adjusted by R14, and it has jumpers on here that you can change the selectivity of the bandpass filter by removing or putting these jumpers in, and it just makes it more selective as you adjust it. The recovered tone comes down and it's rectified by Q3, and it forms a positive voltage across C14. That positive voltage turns Q4 on, which turns the audio gate Q5 off. With Q5 off, the high pass filter through Q6 is enabled. So as the input receive audio, the voice comes through, it's applied through this emitter follower to the output on pin 7. To generate a Ctcss tone, you ground pin 5. And what happens then is Q1 is turned on And when Q1 turns on, it basically shorts this point to ground, which removes the tone from going on through to the decoder. Q2 at the same point is turned on. And what this does is creates a feedback loop through the bandpass filter, and it creates an oscillator. And it generates a sine wave, which is the same as the center frequency of the bandpass filter. Both the encoder and decoder tune to the same frequency using R14. That tone is coupled through R21, R22, and C11 to pin 8. The level is adjusted by R21. Okay, let's see if this thing actually works. I've wired it up to a breadboard, applied 12 volts DC. I've connected the pins on the circuit here. So we have power on the red, black is the negative. Pin 8, which is the brown pin, is the tone out. So now the orange lead here is pin 5. Grounding that should give us a tone output. I'm going to turn it up a little bit. So I'll ground pin 5, and there's the tone. You can adjust the frequency. I'll have to hook a counter up. You can see it expanding a little bit. And then of course, look at the response time of this thing. Builds up slow. It has a slight time constant. Anyway, it's generating a tone. I'll put it on a counter later to adjust the frequency. Next step will be to see if it will decode a tone. So I'll apply an audio input, and we'll see if the decoder works. So stand by. Okay, now I'm going to test the decode function here. So what I'm going to do, I'm going to feed an audio signal in here on pin 3, and I'm going to monitor the collector of pin 4 at this point here. When I detect a tone, when Q4 turns on and grounds the collector, the DC level here should drop down to ground. So we'll see if that happens. So here's the test setup. And since we're using an old tone encoder, decoder, I thought we'd use an old oscillator. This is an old HP200 vacuum tube oscillator. I'm feeding that into pin 3 of the encoder, decoder, and I'm measuring here at the collector of Q4. So when I detect a subaudible tone, this point will go low. So now, if I can get both in view here, I'm going to tune the oscillator here, and watch the scope. At that point, the DC level drops, and that's the point that the decoder is set to. It looks like about 127 cycles. So here I'll tune it off again. DC level's up, and when I hit it, it's very narrow too. You can see I'm only turning it just a hair to get it to decode. Now then again, that frequency that it's tuned to is set by this pot here, 10 turn pot. The output level is this pot here. Now these jumpers here can be taken out, and that will change the range of frequencies that you can decode. Here I can show you better on this one here. If I take these jumpers out, I increase, looking at the schematic, that's jumper J2 and J4. No, J1 and J2. Sorry about that. Anyway, J1 and J2, if I take those two jumpers out, I tune in the low span. This has 4 different ranges you can tune, and they go all the way through the subaudible tones. So anyway, that confirms that the unit is working. And I had to attenuate the output of the audio generator. This is an old generator that goes way back. It's vacuum tube, and setting the level with the amplitude here is kind of tough. So I had to add some attenuation, and I'm driving that into the pin there. So once again, we can tune all through the range here. That level's high, and as soon as we hit the frequency it's tuned to, and you can see it's just very narrow. Anyway, that's the tone encoder decoder. I got let's see, 6 of these. I think I got these at a Hamfest many years ago, and I stuck them in a box. Didn't do anything with them. Didn't have any information on them, but luckily I checked their repeater builders page on the internet, and they actually had some documentation on this. That's where I got this schematic. So anyway, I'm going to use this in an old transmitter I have that doesn't have PL encode in it, so that might be a future video. So I hope you enjoyed it. That's it for this one. See you next time. Bye.